Where did it all begin? 13.8 billion years ago, the universe started out as an extremely hot, zero-volume entity of infinite density called a singularity. Then, in an instant, this singularity began to expand outward in an event known as the Big Bang. As time progressed, the universe has continued to expand outward in all directions from that singularity. You can think of it as a continuously inflated balloon. It just keeps expanding outward. And it's actually expanding faster and faster over time. This initial expansion happened in a fraction of a second. And in that expansion, the universe started to cool down. Less than a second later, the particles that make up atoms begin to form. This process takes a long time. It wasn't until a few 100,000 years later that the first atoms formed. Now we're cooking. At this point, we can actually observe what happened by studying the cosmic microwave background, or CMB. The CMB is like an echo of the Big Bang. It's the furthest back we can see with our telescopes. We'll talk about the CMB more in a bit. When I say see, I mean observing radiation, because there was very little light at this point. So little, in fact, that as the universe continued to expand and cool for a few million years, astronomers called this period the Dark Ages. Eventually, temperatures cooled, allowing heavier elements to form, gas to collapse, and also allowed matter to start clumping together to form stars and galaxies. After a few 100 million years, the first stars formed, and after a few 100 million more years, the first galaxies formed. Astronomers determined this using two types of evidence: the cosmic microwave background, CMB, and redshift. Cosmic microwave background is the oldest electromagnetic radiation in the universe observed by astronomers. It is the snapshot, or remnant, of the energy released when the first atoms formed after the Big Bang. Scientists can study complex patterns in the CMB and tease out the origins of the stars and galaxies we have today. Let's dive into how scientists can tease out those complex patterns to learn more. The Doppler effect is one tool they use. The Doppler effect is the reason a car horn sounds different coming towards you versus going away from you. This happens because the sound waves are changing in frequency as the car is moving towards and then away from you. Scientists have a special method of detecting objects that are moving away from us called redshift. Redshift is the Doppler effect with light. The universe is expanding, and that means it is the space between objects that actually stretches. This causes objects like stars and galaxies to move away from each other, which in turn means that any light in that space will also stretch. This stretching of light shifts that light's wavelength to longer wavelengths, which are red, hence redshift. The higher the redshift, the further away an object is from us. Edwin Hubble was studying galaxies at various distances from Earth and observed that the light from these galaxies was shifted to the red end of the spectrum. This meant that all the galaxies were moving away from us and each other. The furthest away objects may shift so much that the visible light shifts into the near and mid-infrared part of the electromagnetic spectrum. This means we need different types of telescopes to study those wavelengths, like the new James Webb Space Telescope. Redshift and CMB are evidence that allows astronomers to conclude that the universe is expanding outward in all directions, which means that the universe had to originate from a central point, like an exploding firework. By measuring how fast the universe is expanding, astronomers can determine how long it has been happening and how it has changed over time.